Okay, hi everyone. I would like to go over milestone 2 and explain how this assignment should be completed. So for step 1, you need to uh, decide about some rooms in a house. Okay, I'm not going to go over the exact assignment, but in this example, I'm going to show a similar problem where we are talking about the kitchen, and we would like to list what types of kitchen utensils are in different parts of the kitchen. Okay, so I chose 4 different areas in the kitchen. I chose my sink, and in my sink right now I have a cup, a fork, and a plate. And I chose a drawer. In there I see a fork, a knife, and a spoon. A cabinet, which contains a cup, a plate, and a bowl. And my counter right now has a plate, a fork, a bowl, a pan, and a glass. Okay, so make it simple, okay? You don't need to choose a lot of items in order to complete this assignment, okay? Just make it simple, because some students in the past have chosen like 10, 20 items per room. So, okay, let me just show you a simple example and you get the idea and you can continue and make it as more complicated as you wish, but I think simple is best, okay, to show that you understand the concepts. Okay, so in step 1, you're asked to write out a description, okay, just write a description of the items. Then you need a roster notation, which is similar to this right here, and the set builder notation, which is kind of odd, but you can write it this way, X, where X is an item in the sink, okay, and I'm missing here a closing curly brace. Sorry about that. Okay, so you need to do this for all of your areas in this example, or rooms in your case. Okay, so let's go to step 3. So step 2, I'm sorry. Step 2 asks you to list the cardinality. Okay, let's go back. So what is cardinality? Is the number of items per set. Okay, so the sink set has 3 items. Drawer set has 3 items, as you can see above here. The cabinet has 3 items and the counter has 5 items. Okay, so this is the notation for cardinality. Then it asks you to decide if some of these sets are equal. Now, equal sets are those that have the same cardinality. So here we see these 3 sets have the same cardinality 3, so these sets are equal. And no sets here are equivalent. Remember, equivalent sets are the ones that contain this exact same items in different order. Order does not matter here, but so in this case, we have no 2 sets which contain exactly the same items. Okay. Now, step 3 asks you to list the universal set. Now, what is the universal set? Okay, a universal set contains everything that we are investigating. Okay, so in this case, it definitely contains all the items in each of our sets. Okay, so start out by looking at each of your sets and write out all the items. So cup, fork, plate, here they are. Knife, spoon. Okay, fork is again here, so I'm not going to write it twice. Okay, so 1 time for fork. So cup, fork, plate, knife, spoon, the extra 2 items from here. And then we have cup and plate are already in, so just add bowl. And then we add the plate is in, fork is in, bowl is in. We add the pan and the glass right here, as you can see. And then I can just list other items found in a kitchen, which are not included in my 4 sets, just to make it more general. The universal set is a universal set. Okay, so I'm just for this example, you're not going to list all the items in the house. Okay, just list some extra items. Okay, so I chose to add frying pan, wok, a pot, and a spatula. Okay, so that's it. Step 3 is done. Step 4, okay, and it asks you for the different notations, as we said above, the roster, the set builder. Okay, you know how to do this. Okay, similar as in step 1. Now, step 4, it says to pick one of the areas and write out the complement of the set. So I picked the drawer, and the complement is by denoting it with this a quote, not a single quote up here. Okay, and what is the complement? Okay, when you try to find the complement, you look at your drawer, which is a fork, knife, and a spoon, and then you look at your universal set. Okay, so you take the universal set and just remove all the items from your original drawer set. So I had a fork, a knife, and a spoon for my drawer. So here, for my drawer complement, I have cup, fork is there, so I just remove it, plate, knife is in the original set, remove it. Spoon is in the original set. So bowl, pan, glass. So I have cup, plate, bowl, pan, glass, frying pan, wok, pot, and spatula. Okay, does this make sense? Okay, so let's continue with step 5. Now in step 5, you need to choose 2 areas, and I chose the sink and the drawer, and create the Venn diagram. Okay, so how do we create a Venn diagram? We put with 2 sets, this is how it looks like, okay? And in your case, it may, here you may have nothing, okay? Because here we put the intersection, the items that belong to both of these sets, okay? So if you check the sink and the drawer, if we go up here again, the sink has a cup, a fork, and a plate, and the drawer has a fork, a knife, and a spoon. So the common item is the fork, okay? And the common item is what we put in here, or any common items. There can be many common items. There can be no common item. Okay, so the fork is here. In the sink, then, we have the cup and the plate. And in the drawer, we have the knife and the spoon. Okay, so that's it. And we can also write, it asks you for intersection and union here. So the intersection is sink, drawer is the fork. These are the common elements, the fork. And the union is all the elements but listed once. Okay, so fork is twice common. It's common, so we just listed once. Okay, so union, yes, is all elements in both sets. Okay, so that was step 5. Okay, and just make sure any extra questions the assignment has, that you answer them properly, like the different notations or whatever. So let's talk about step 6. Okay, step 6 now is a more complicated Venn diagram where you're asked to choose 3 areas. And I'm choosing the sink, the cabinet, and the counter. Okay, so this is how the Venn diagram looks like. It's a bit more complicated. So just for ease of reference, I'm including the items in each set right here. Okay, so we can, just don't have to scroll back and forth to check them. So let me take 2 of these at once and decide what goes in where. Let's take the sink and the cabinet. Okay, so note here that I denoted the common items with like the plate here has a straight line, and here there's a wiggly line under cup because these items are the same, and a dashed line under bowl. I'm sorry, the plate is also in all 3 of the sets, okay? So the bowl has dashed line. Okay, so let's take sink and cabinet, okay? Do they have any common items? Well, yes, they do. They have a cup, a plate, and that's it, okay? So these 2 items are going to be listed in this area over here, okay? But notice that we have this area right here. And this is the area which is common in all 3 sets, okay? So let's check, is the cup or the plate common in the counter set? Well, yes it is. We have the plate here. Okay, so since the plate is common in all 3, we put the plate right here in the middle because it's common to all the circles, the sink, the cabinet, and the counter sets, okay? And the cup we talked about previously, we put here in this area because both the cup and the plate are common in the sink and in the cabinet. Okay, so it's this area right here. This whole area is the common to both sets. And this area right here is the common to 3 sets. Okay, to all 3 sets. So in the same fashion, let's take other 2 sets. Let's take the sink and the counter. Okay, do they have any common items? Well, let's see. They only have the plate, okay? So the plate we took care of. So then we just, oh, and they have the fork. I'm sorry, I forgot to underline this. Okay, and the fork, okay. So the fork now has to go here in this area because it's not common. It's not in the set cabinet, okay? Because if it was, we would put it right here. But since it's only common for sink and counter, we put it in this area right here. So this is the only common between sink and counter. So this is their intersection, along with the plate, of course. And we just fill out the rest of the circles with the remaining elements. So the sink, we have all 3 elements written, nothing else to fill out here. But for the counter, we have written a fork, a plate, and then let's look at this, the bowl. Okay, the next one is the bowl. Does the bowl belong to another set? Well, it does. It belongs to the cabinet. Okay, so we cannot put the bowl in this area. We need to put it in this area because it's common with the cabinet. It's in the intersection. Okay, so you put the bowl here and then go to the rest of the item. We have the pan. Pan is only in the counter set, so we put it here. And the same for the glass. Okay, and the cabinet is also complete because it contains 3 items, and here they are. Okay, and the intersection is also visible here. Okay, so this is how you complete a Venn diagram with 3 sets. Now, lastly, let's go to step 7. Okay, so step 7 asks you to prove the second De Morgan law. Okay, now in my example here, I'm going to prove the first De Morgan law. Okay, and the second one is up to you. So you're going to prove the second one based on what you see, the method that you're going to see right now. Okay, so how do we prove? What does this law say? This law says that the complement of the union of 2 sets is equal to the intersection of the complements of each set. Okay, so how do we prove this? Well, assume that P is the set A union B complement, and Q is the set A complement intersection B complement. Okay, our goal here is to prove that P and Q are equal. And how are we going to prove this? We're going to prove that P is a subset of Q, and Q on the at the same time is also a subset of P. So since P is a subset of Q, while Q is also a subset of P, then the only logical explanation is that P is equal to Q. Okay, so let's prove the first part, that P is a subset of Q. Okay, so let's take X, an element that belongs to the P set. Okay, what does this mean? This means that X belongs to A union B and complement. Okay, so the complement of all this. Okay, because we said that P is exactly this. So since X belongs to this set, then we know that X does not belong to the complement of this, which is just A union B. Here it is. Okay. So since X does not belong to the union, this means that X does not belong to A and X does not belong to B. Because if it did, then it would belong to the union, but it does not belong to the union. Okay. So we continue on from here and say that since X does not belong to A, it means that X belongs to the complement of A. Okay, so the complement of A is everything besides A. Okay, makes sense? Same thing for B. For X belongs to B complement. Okay, so since X belongs to A complement and X belongs to B complement, then the logical here reasoning is that X belongs to the A complement intersection B complement. Okay, makes sense because X belongs to both of these. Okay, so what is this then? Let's look it up here. This is Q. So this means that X belongs to Q. So what did we prove here? We proved that X belongs to P, and we proved that X belongs to Q. So this means that for all X that belong to P, these X belong to Q. So definitely we know that P is a subset of Q. Q may contain more elements, but we definitely know that Q contains all elements of P. So P is the subset of Q. So we proved the first part. Now let's prove the opposite, that Q is a subset of P. So we do this in a similar fashion. We take Y, an element of Q. Now we start out with the set, the other set, the Q set, this one. So Y belongs to Q. This means that Y belongs to A complement intersection B complement. This means that Y belongs to A complement, and at the same time, because it's the intersection, Y belongs to B complement. This means that Y does not belong to A, because it belongs to A complement, and Y does not belong to B. This means that Y does not belong to the A union B, because if it did, then it would belong to A or it would belong to B. Okay? This means that Y belongs to the complement of this, which is A union B complement, which in fact is P. So Y belongs to P. So for all Y that belong to Q, we proved that these Y belong to P. And therefore Q, with the same reasoning, is a subset of P. So from these two, P subset of Q and Q subset of P, we can conclude that Q is equal to P. Okay, guys, I hope this helped you complete our assignment this week. Thank you so much.